Look at this banyan tree. This is a typical banyan tree. A large one could weigh 10, 20,000 kilograms, but a typical banyan tree would weigh about 4,000 kilos. Now here is the question. Where did this 4,000 kilos come from? This is what we will discuss today. I'm your host, Gurvinder Singh and Guru Wonder. Welcome. Now to the question of where did this 4,000 kilograms of mass come from in this banyan tree? Some of us will say it came from the soil, some will say it came from the water, and some will say from the nutrients. They're all partly true, but not completely. Let us look at an interesting experiment, fascinating experiment conducted by a Flemish scientist called Jean-Baptiste van Helmont. He took 140 gram willow sapling, planted it into a pot of soil weighing 90 kilograms, dry weight, and then he watered the plant for 5 years, and it grew. The 140 gram willow plant sapling grew into a 76 kilogram plant. He took the weight of the soil, dried it again, and found that it had lost only 56 grams. Now here is the question. If that didn't come from the soil, where did that 75, almost the complete 76 kgs of the plant came from? What? Where did it come from? Obviously it didn't come from the soil, the mass. Now let's look at water. A moderate-sized banyan tree could easily suck up 500 liters of water a day. Goes up, and water is made up of hydrogen and oxygen. 2 parts of hydrogen, 1 part of oxygen. And when the plant takes it up, the plant breaks down this water into hydrogen and oxygen. It releases the oxygen into the air and keeps the hydrogen. I will tell you in a moment what it does with that. So obviously water is not getting, not adding to the mass, any significant to the mass, because if what oxygen is being released, hydrogen is the lightest element we know of. It can't add any mass, leave alone 4,000 kilograms of it. So oxygen is exhaled by the leaves, and so that means the water didn't add to the mass. An analysis of the dry weight of a tree reveals that majority of it is actually carbon, a dense, heavy element. The 4th most common element on Earth. And as far as nutrients, an analysis reveals that nutrients like nitrogen and potassium and iron and zinc and all these other things constitute no more than 2% of the mass of the tree. The soil does not have much free carbon. So where did all this carbon in the tree come from? Out of thin air. In a sense, the tree is a solid column of solidified carbon. Not only trees, but every living creature is made up of carbon. Our brains, our bones, our skin, our muscles, everything is made up of carbon. Every plant has carbon. Everything that exists, almost everything that exists, is made up of carbon. Our muscles, our bones, everything come from food that we ate from plants, or from animals that ate plants, or from animals that ate other animals. But the root base of life is carbon. When we say the word organic, we mean is that anything that has carbon in it is called organic in chemistry. And the importance of carbon is it has the ability to make long chains and make complex compounds. Now here's an interesting fact. Millions of planets exist on this universe. They have diamonds, they have gold, they have platinum, they have valuable elements, rare earths, lots of this thing everywhere. But do you know, the only known planet to have wood is Earth. And it is a great privilege for us to live on this planet where we have wood. Now you tell me, is it not worth dedicating some time and resources to preserve and grow forests, cultivate gardens and plants, or have a small home or terrace garden? Well, I hope you found this video useful. If you did, please do press the like button, share and subscribe to my channel. This is Gurvinder Singh signing off. Thank you.